So before I start, because I'm not getting notes on my test, I need to write what at the top?
SOHCAHTOA.
SOHCAHTOA. So I have S for what function? Sine. C for cosine. And T for tangent. So sine is what over what? Opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. You need to be writing it on your paper, right? Okay, I've helped a couple people today, and the first thing I said was, where's your labels? And they're like, I don't understand what I'm doing. What did I say from minute one? As soon as you get to a problem, label things O, A, and H, right? And it clears things up. So first of all, we're looking for the largest acute angle. So would it be across from the 5 or across from the 12? It'd be across from the 12. So we're looking for theta. So I'm going to write a theta. It's just a circle with a line through it.
A theta?
A theta. Now, this triangle happens to have all 3 parts, correct? So I get to pick which function I want to use. And I'm going to actually write out all 3, but I'm going to choose sine for this first one, okay? So what we would do is we would have the sine of theta equals the opposite. I forgot to label. So this is opposite, hypotenuse, and adjacent. If you always do a hypotenuse first, then opposite, adjacent falls in. That's usually one people struggle with. So sine is opposite over hypotenuse, correct?
Hey, Dakota, that's what you do in first grade numbers.
Dakota and I got it figured out 6th period, didn't we?
Yep.
Okay, so we have a problem. I have the right-hand side, everything on it, don't I? And yesterday you were looking for that. What I'm missing is the sine of the, no, I'm missing theta, excuse me. Sine is a function. It's a function like the square root or the absolute value. Those are things you have to do, right? And I can't get theta out of that function unless I get it out of the domain. So a domain is an x value. We put it into a function, and this is all you need to know about this. You did domain and range last year. We're going to keep talking about it next year and keep talking about it the year after that. It's not a concept you need to know completely right now, but you need to understand a little bit about it. We put x's into a function. Those are called inputs, domains. What do we get out? Y's and outputs, which are called ranges. So I have a problem where I have the output, but I don't have the input. So I need to switch those two things. I need to switch these two to change places. So how I do that is with an inverse function.
What?
Okay, and I'm going to briefly explain the inverse function. An inverse function interchanges the inputs and outputs so I can use it. So what we do, we have inverse sine of a value. Oops, I forgot my 1. And we have inverse cosine. What is different about what I'm writing?
Negative.
That negative 1 exponent, right? And then I have inverse tangent. So when I have these inverse functions, these aren't angles anymore. This is a ratio here. And this is a what? Ratio. And this is a what? Ratio. So that's what we'll be using today. We will decide whether we have the information to use sine, cosine, or tangent, and then we're going to put the ratio in there. So I'm going to show you how that works. So sine of theta equals 12 over 13. We are going to take the inverse sine, so you have to put the negative 1 there, of 12 over 13. So do you see how, and that is going to equal theta. Do you see how the ratio and the theta switch places? Now, could I put this in a calculator? Yes, you don't know where the button is, but could I put this all in the calculator now? Yeah.
I know where mine is. I did that yesterday.
Yeah, and that's wrong. So, when we're looking for an angle, we're going to use what? Inverse functions. So, looking for angle. And we called the angle theta. We're going to use inverse functions. You need to have that on there. If you're looking for an angle, you're going to use what kind of functions?
Theta.
Inverse. So, if I was using sine, it would be opposite over hypotenuse, yes? What if I was using cosine? It'd be adjacent, so it would be what? 5 over 13. And what if I was using tangent? It would be 12 over 5. So we will come back to that, and I will show you that all of them equal the same theta. Okay? But the reason why I could pick is because they gave me what? Am I missing any sides? No, I'm not missing any sides. They gave everything to me. So that was nice of them, but your worksheet doesn't give you all three.
That was nice of them.
Yeah, it was, because you could pick either one, like any of them, as long as you did them right. Okay, so now we're going to go down to the example. Did they give me all three sides? Nope. So, since they didn't give me all three sides, well, I guess we just start with angle A first. What do you think? Yeah? So we have the measure of angle A equal to, well, angle A is here. My hypotenuse is where? Here. My adjacent is, my opposite is there, and my adjacent is there. So I have the adjacent and the hypotenuse, so which function do I have to use? I have to use cosine, because cosine is adjacent and hypotenuse, correct? So I'm looking for an angle, so I'm going to use the what function? Inverse function. So inverse cosine, and how do I show inverse?
The negative.
To the negative 1 power of, and just put your ratio in there. So adjacent over hypotenuse.
Is that all?
Well, then we put it in a calculator. But yes.
What?
Okay? So now I want angle B. Correct? So the measure of angle B. Well, here's B. The hypotenuse is still the hypotenuse, correct? So I'm going to color it in blue. But where's the opposite now? 1. And the adjacent is down there. Now, in your worksheet, I'm not asking you to find both angles, okay? I'm just asking you to find one so you won't have to do two different colors or anything like that. So I have the opposite and the hypotenuse, so what function do I have to use now? Sine. Kale, did you have a question? No, ask it if you do.
I don't.
So I have opposite and hypotenuse, so that sine is opposite and hypotenuse. So when I'm looking for an angle, I'm going to use what kind of the function? Inverse. So inverse sine. And how do I show inverse? Negative 1. And what is the opposite of B? 1. And the hypotenuse is 4. Does that make sense?
So what is it, negative 1?
The negative 1 just shows you that it's an inverse function. You don't have to worry about it. I will show you where it's at on the calculator, and you push the button. Okay? In Algebra 2, you learn how to find those. Not in here. Okay? And actually, you never find them with sine, cosine, and tangent. They're just there. So I want you to try this one on your own. This one's all three, so you get to pick. You're going to find A and B. If you get done with that, go to the one down here using S and T. I guess I'll do all three since I'm letting you pick.
We have to do it all.
No, you don't have to do three. I'm doing all three so you can check your work. You do not have to. If you want to, that's up to you. I wouldn't want to. Assuming you guys could do it one way when I did it 6, right? Okay, did you get your A right? Yes, whichever one you chose. Now, why could I choose any one on this?
That's right. They gave you all three.
Because they give me all three sides. Okay?
What's the difference?
What do you mean? What's nothing? When I put this in the calculator, I will get the same answer every time. If this is 36, this would be 36, this would be 36. I will show you that. But the reason I didn't have to get the right one, quotes, is because they gave me all three sides and I could pick the one I like. City, which one did you pick? Sine, cosine, or tangent?
Tangent.
Tangent. Dakota, what about you?
Huh?
Which one did you pick? Sine, cosine, or tangent?
Sine.
Sine. Which one did you pick? Tangent. Anybody put cosine?
I put cosine for the first one.
You put cosine for the first one? Okay, does it matter? No. Most people would pick sine or tangent. That adjacent side just messes people up. Is that the one that's causing you guys issues if it's any of them are? Okay, so now try this one because this one is going to be specific because they only gave you 2. Well, this is your whole worksheet.
I'll just wait.
No?
I'll wait till you do it.
Help me. Yeah, help me. Okay, we're going to do S first.
Okay.
So let's label for S.
So 10 is hypotenuse.
So 10 is hypotenuse.
And
4 is the
the opposite.
opposite.
And the last one's adjacent.
Oh, can I stop you guys real quick? I have 4 and 10. Can I reduce that?
Yeah.
Should I?
Yes.
Might as well. So what does it reduce to? 2 and 5. If I do it first, do I have to do it later? Nope. Okay. So, Amber, I got S, right? And I have the opposite and the hypotenuse. So what function is opposite and hypotenuse?
Is it sine?
Sine. And since I want an angle, I have to use the, what's that word?
Inverse.
Inverse. So inverse sine. And what's the opposite?
2.
2? Yeah, I think I wrote 5 twice.
Yeah, that's
Okay.
why I was looking at it funny.
Yeah, I know. I don't know what that was. It really wasn't a 5 either. So 2 over 5. That's it. Okay, so now we got to do sine of t. Or not sine of t, the value of t. And I'm going to tell you on your homework, I'm only asking you for one angle because it gets kind of confusing. So of t, I have not the opposite, but the adjacent
Adjacent.
and hypotenuse.
Hypotenuse.
So what function is that?
Cosine.
Cosine. And if I want an angle, I'm going to use the what? Mm-hmm. So inverse cosine of what?
5 over 2. 2 over 5.
2 over 5. Okay, how's it going, guys? Good? Okay, so now, all the examples. I'm going to show you how to put in your calculator, okay? So I'm going to show the yellow one first, and then I will show you Desmos when I put in all 3. So on the calculator, we have the inverse cosine of 1/4. So on these, where did I find the trig stuff yesterday? Under trig, right? So I hit second trig, And I only see sine, cosine, and tangent, but if I hit the down arrow, look what happens. I have inverse sine, inverse cosine, and inverse tangent. So inverse cosine is 5, so I'm just going to push 5. And then I'm going to put 1 divided by 4.
And then we should get 75.52.
And you should get 75.52, so approximately 75.5. And approximately 75.5, and don't forget your degree. That makes sense how to do that?
For me, it is.
Okay. I'm going to do one more. Now, again, is the decimal the more important, or is the inverse cosine of 1/4 the more important? Which one's more important to me? The setup, the inverse. So then I have the inverse, so second tangent. I need inverse sine. And I'm going to do 1/4 again. And I get 14.5. Now, did I have to use my equation to get my second angle after I have the first one? Why? If I have 75.5, did I have to use this equation to find 14.5? No, you could have subtracted it from 90, right? But what happens if I found 75.5 wrong? What's going to be wrong about the next one? Your answer. Okay? So I want to show you right now that these three turned out the same, right? Because I told you that all three of these would come out the same, didn't I? So let's look.
Are you doing the last example?
No, I said that at the beginning.
Hey.
I'm not listening. Okay, I need to go to Desmos. You guys see Desmos at the top? There it is. I'm going to make this one on the
Yeah,
right.
that one kind of freaked me out.
And this one, no, it's actually pretty easy.
No. It is.
So, I've got the sine, look right here, I have the inverse sine of 12 over 13, the inverse cosine of 5 over 13, and the inverse tangent of 5 over 12. What do they all equal? 67.4. So, approximately 67.4 degrees. Now, on those three sides, when they give me all three, does it matter which one I pick? No. Okay, again, your worksheet's not going to have all three. They were nice on there and gave you all three, but I'm not going to give you all three because I'm not that nice, evidently. Questions? Do we need to put more in a calculator before we go? Okay, so we're done.